Okay, so for this lesson, it's really important that you copy everything in here and you save it, okay? So let's go. Ready? Go. All right, now that you guys are done copying everything, let's talk about this really fast, right? So coordinate proof is a style of proof that uses what? Coordinate geometry and algebra. Just in case you don't understand what coordinate geometry means, that means, we have those, little graph paper, and then we're going to use them, like draw little, triangles and all that stuff to prove things. And then we're going to use numbers as well. That's what algebra means, okay? The first step is obviously to position the given figure in the plane, and you have to know how to do that correctly. And so they are giving you some strategies over here. You have to use the origin as a vertex. What that means is if you have the number line like that, okay, you want to go ahead and use, if you have to make like a triangle like this, one of the vertex should be at the origin at 0, 0, because it's easy for you to calculate that. And then you want to try and keep the figure in quadrant 1. Okay, so that means when you draw pictures, okay, you want it to be like over here. Most of the time they want your pictures to be right there. Okay, because that's the first quadrant and it's usually easier to calculate with positive numbers. And then another thing, center the figure at the origin, because sometimes you have a graph like this, and if you want to draw a triangle, it's really nice to have the center right here because it's easier for you to calculate stuff. All right? And then center a side of the figure at the origin. What that means is, if you have something like this, if you want to center a side at the origin, you can just make sure that you have a side like this. Okay? It's right here. Or use one or both x's as sides of the figure, and that's exactly what I did. I drew my triangle, and this side is on the y-axis, and that side is on the x-axis. Again, these are just some strategies you need to use in order to make sure that your calculations go easy. Okay? So now, based on all this, I'm going to go ahead and skip to this question over here, even though we're not ready for this question yet. And then I want to ask you, based on what we learned right now, okay, we have 4 graphs over here. I'm going to make it a little bit smaller so you can see everything. Okay, so I see 4 graphs over here. And out of option A, B, C, D, what do you think would be the best one to use when we're trying to do coordinate proofs? What would be the correct answer, guys? D? B? All right, so some people said B, some people said D. Anybody else? C? Anybody else? You guys are all horrible. The correct answer is A. Okay, because look, we just talked about this. When you draw your shape, it's much easier to have the sides be the x and the y axis. It's much easier for you to calculate. For example, if you want to use this triangle and we want to talk about the height, look, the height, if you just look at this number, is a 6. But you gotta actually, the height is 1, 2, 3, 4. So to explain that the height is 4 units tall, you have to say, oh, you gotta go 6 minus 2, right? And it becomes more complicated when instead of using numbers, you use letters. For example, this is y sub 2 and this is y sub 1. Then you gotta say, in order to find the height of this triangle, you gotta go y sub 2 minus y sub 1, right? Wouldn't it be so much easier if you just say, oh, the height of this triangle is y. The base of this triangle is going to be x unit long because that's 2 right here. If you want to use this one, you can do the base easily. But for this one, the height, you have to say 6 minus 2, right? Or y sub 2 minus y sub 1. So that's the reason why we have some rules on where you put your shape on the graph paper. Okay? So now let's do another practice question. Just on that part, and that's only like a portion of the question, but let's take a look at this. We have 4 graphs, A, B, C, D. Which one is a good one for you to use? Huh? B? No, because it's not really stuck to the x and the y axis, right? Yeah, it's A again, right? Because it's touching. All right? You got that? All right, good. Huh? No, don't write this down because we're going to do this next. I'm just trying to have you practice this. Okay? So that is only half the question. If you look at this question over here, Okay, this is only part 1 out of 2, and the real question is right here. And so that's what we're going to be trying to do today. And yes, you are advanced, right? You're doing great. I am so proud of you. And so what you're going to do right now is obviously you're going to copy this question. Okay? You're going to copy this question, and you're going to, I don't know if you have enough space on your graph paper, right? But go ahead and on your graph paper I gave you, please copy all the words. Every single word, okay? And if you cannot read, you are welcome to go into your own online textbook. This is the very first your turn question in module 25.3, okay? So please go ahead and copy this question up to here. All the way up to here, okay? Ready? Go. Alright guys, so what we have to do now is we have to read the question to make sure that we know what we're doing, guys. And the question says, select a graph containing the correct position. So earlier we did that and we already selected our correct graph, which was graph A. And I want you to go ahead and draw that graph in your paper, and I'll scroll down in a bit. But let's finish reading this. Then complete the explanation that shows that the area of triangle DBC is 1/2 of the area of triangle ABC. And look, ABC is a right triangle with legs of length 2 units and 4 units. I'm going to highlight that with a different color because this is something that we have to remember when we are drawing our graph, right? So we have to draw a right triangle that looks like this. And then the leg length is 2 units and 4 units. Whether this is 2 and this is 4 or it's the other way around, it doesn't matter. But we have to make sure that one side is 4 and the other side is 2, right? So I'm going to scroll down a little bit so you can actually copy down this graph A. So please make sure this length is 4 over here. This is the key information, okay? This length has to be 4. And then this length over has to be 2. And then you have to draw a triangle like this using the x and the y axis. And you're going to draw that graph at the bottom half. Well, you know what I mean, right? At the bottom part of this graph paper. All right? And don't forget, each square is worth 1 square here. Okay? So please go ahead and copy that right now. Ready? Go. Alright guys, so now that we are done, okay, drawing this, we have to try and go back to the question, right? So when we go back to the question, we just talked about this, but we have triangle, DBC is 1/2 of ABC. So ABC, as you can see, is the whole triangle. You can't really see, so I have to scroll down again. So you gotta prove that ABC, which is this whole triangle, the area of this whole thing is going to be what? Twice as big as the area of this other triangle, DBC, right? So whatever the area of this triangle is, times 2 is going to be the blue one, okay? And we have to prove that. So let's go ahead and try to do this. So whatever you write is going to be on the graph paper below your graph, okay? I'm just going to write everywhere here because I just don't have space anywhere, okay? So there you go. The first thing you have to do is we have to find the area of the big triangle, right? And then what do you think we have to do next? Find the area of the small triangle. And then we gotta see if really the area of the small triangle is only 1/2 of the blue triangle. And once you figure out that the orange triangle, the area of the orange triangle is really only 1/2 of it, then we are done. Okay? So I want to go ahead and find, first step, I'm going to go ahead and find the area of triangle ABC. Okay? So then somebody tell me, I want to try and find the area of this big triangle here. What is the formula I have to use? Okay, yeah, 1/2 of base times height. And that's the area of a triangle, okay? So the area of a triangle is 1/2 of base times height, okay? So in this blue triangle, how long is my base, guys? How long is my base?
4, 2.
My base is down here. Okay, so it's 1, 2. We can actually count 1, 2, but another way to do it is just look at this number 2 because we started from 0. So instead of base, I'm going to put area of triangle ABC is going to equal half of the base, and the base is 2. And then I need to find the height. How high is my height? 4. So I could just look at this number, right? So I'm going to go ahead and put 4 over here, right? So now let's go ahead and calculate this. What is 4 times 2, guys? 8. And what is half of 8? 4. So the area of triangle ABC is obviously 4. Alright? Now I'm going to move on to the second step. And the second step is to find the area of triangle DBC. Okay? We have to find the area of triangle DBC. So then it's the same formula. The area of a triangle is half times the base times the height. Right? So then let's go ahead and find the area of triangle DBC. DBC. And that's going to be half of, tell me what's the base for triangle DBC, guys? 2 is still the same. The base is the same, right? So we're going to use 2. But then what happened to the height, guys? How high is the height? Yeah, 2. 1, 2. You can count it, or you can just use this number right there, right? So now let's go ahead and calculate this. What's 2 times 2? 4. What is half of 4? 2. 2. Good job. So the area of triangle DBC is now 2. Alright? So now as you can see, we have the area of triangle ABC and area of triangle DBC. The third step is to compare. Okay? Compare the area of triangle ABC and area of triangle DBC. Alright, so we have a 4 and a 2, right? So tell me, what is the relationship between the area of triangle ABC and the area of triangle DBC, guys? What is the relationship between the 4 and the 2 areas? What is half? Good job! The area of triangle DBC is half of the area of triangle ABC, right? So let's write this down. We compared it, and now we know that the area of triangle DBC is half of the area, the area of triangle DBC. And we know this because 4 divided by 2 is 2, right? And guess what? We are done.